for example, if you think about say a standards given context like the one that we used already in this module with P of 0.03, and if you think about, well, we've already dealt with a sample size of 400. I might compare my control chart for a sample size of 400, or control limits for a sample size of 400, to control limits for a sample of size 100. You get this kind of a thing. So if I want to talk about center line for p hat, in both cases the center line is at 0.03, but the lower control limits for p hat and the upper control limits for p hat change with the sample size. In particular, for a sample size of 100, there is no lower control limit. If you make 0.03 minus 3 standard deviations of p hat, you wind up with something negative. It makes no sense to state a negative lower control limit, so we'll say there is none, as compared to 0.044 that we've already calculated. This number is 0.0556. The corresponding number is 0.0812. That is, the scenario is this. If this is p hat that's being plotted, this is the center line of 0.03. If we're talking about a small sample size, we get relatively wide limits. If we're talking about a large sample size, we get relatively tight limits. And that sometimes runs counter to people's intuition, but again, this is exactly right. If I have a large sample size, if I have n of 400, then I learn a lot about p from a sample, and I want I learn a lot about p from a sample, and I want even small deviations from 0.03 to tell me that there's been a change. So the point is that this is a reflection of the fact that big N means big information. I've learned a lot about P from my larger sample, and so I'll tolerate less deviation from 0.03 before I will declare that there's been a process change.